Good morning, everyone. I'm Nico from Group 8, and we're going to present Task 4, which is determine the dimension which will make surface area of the drink as small as possible. The members are Kaden Cheong, Chou Zhiyan, Ong Le Shen, and Pang Jinghao. The information given for this question was when metal prices rises, the profit of manufacturers decreases. Companies want to use the dimension to make the total surface area as small as possible. The information required to accomplish the task was the surface area of the drink can and the dimensions to find the volume.
Here are some of the assumptions we have. We assume that the thickness of all the cans are the same, which is 0.1 mm. We assume that the required volume of the can is the same, which is 300 ml. We also assume that all the cans are made of the same material, which is either aluminium or metal. Lastly, we assume that all the cans are in a single shape, such as sphere or cylinder. Here are some of the formula required to solve this problem. Firstly, we have to find the surface area of the can. We need to use 2 pi RH plus 2 pi r squared. To find the volume of the can, we use area of the base times height, which is pi r squared h. Here are some assumptions we made to get our solution. For the first solution, we try making the height and radius into unknown variables by using a formula for height to replace height in terms of r, which is radius. This allows us to make a new formula and then substitute number for radius, which can allow the solution to be solved. For the second solution, we tried making the can into a sphere. A sphere has the smallest surface area for the same volume.
Hi, I'm Kaden, and I'll be presenting solution 1. So let SA be surface area and R be radius and H represent height. This is the formula for the surface area, and this is the formula for the volume. Since we want the volume to be 300, we can automatically replace V with 300. Now let's make H the subject for this formula and replace H in the surface area with this. So the surface area becomes 2 pi r times 300 over pi r square plus 2 pi r square. We can simplify this to become 600 over r plus 2 pi r square, or surface area times r equals to 600 over r square plus 2 pi r. So now we can choose what the radius should be. Now let's choose 4. Surface area times 4. Now that equals to 600 over 16 plus 8 pi. SA surface area would be 251 to 3SF. Now let's put the 4 into this solution. Now height would be 300 over 16 pi, which would equal to 5.968325. Here is a table of possible radius and the results through the formula. And according to this entire table, 4 would be the best integer since we want the smallest possible surface area.
So I am Jin Hao and I will be here to explain the second solution. Our second solution is that we can make the can into the shape of a sphere. The reason behind this is because of all the possible shapes for the creation of a drinking can. The sphere actually have a smaller surface area, which allows the drinking can to be smaller than expected. For example, bus balls, a drink that is made in America which uses a spherical shape for its can. So the formula behind it is that the surface area formula equals to 4 pi r squared. Then the volume formula is 300 equals to 4 over 3 pi r cubed. So we bring the 4 over 3 over and it will become 400 equals to pi r cubed. And we want to make r the subject, so it will become 4 over pi equals to r cubed. So we'll express it in indices form, which is 400 over pi to the power of 1 over 3 equals to r. So we'll sub r into the formula for surface area, which will give us 400 over pi to the power of 1 over 3 times 2. So we'll times 2 to 1 over 3, which will give us 4 over pi 2 over 3 when we when we multiply to 217.153.
Hi, I'm Jiren, and our preferred solution is solution 1, which is make the height and radius into unknown variables. The reason is because if we use spheres, it can easily roll off surfaces. You might be wondering, why not make the base flat? If we do that, it will not be a sphere anymore and it will be a completely different shape. Some constraints we face is the manufacturing time. Since we had no idea how long it would take to manufacture cans in this shape and size, another constraint that we faced is that the fact that we had no idea whether the material we choose to make this can out of is suitable to create this type of cans. In the real world, there are more financial concerns other than just the cost of the can itself. One very common example being the ease of transporting it. For our cans, it may not be the best shape or size due to its height to radius ratio, which may affect how many of these cans can fit within each cubic meter of space of a truck could carry. So how our modeling strategy can be extended to related problems. Manufacturers of different companies and industries, such as bottle making, spray cans, or just the ordinary soda cans, they can use this method to minimize the cost of materials needed to produce their products so that they can earn more income compared to other methods of bottle making. These are some of the photos taken during the project. Now it's time for the Q&A session. Thank you for listening. Please use the rubrics to access our group presentation. We are Group A.